if we consider that Berthold took the concept of a single reed, the shape of the reed, what he did was he made a tool that you could feed the brass into the machine and it continually stamped out reeds. And what he did brilliantly was he inverted the tool. So this is the bottom, these black parts here are, if we look here, the bottom of this tool. So whereas this is the shape of a reed, this is the inverse of the shape of the reed. And what he did, we consider this would be the punch that comes down and punches this shape out. It punches this shape, which is not the shape of a reed. You can see that this would come in here. This would be set up in a tool. Obviously mine's made out of wood, and it would punch out. And what he did, this is my Blue Peter moment, he took a sheet of brass like this, and the first cut, if we look here, he would feed the brass in, and the first cut would take that away. The tool would come down. I can find the tool. The tool would come down and it would cut that section of the reed, this part here. The operator then pushed the brass in to a stop here. This would come down again, and this time it would remove this section, this middle section out. You can do this. And it would take out this middle section. And what you'd be left with, this would be scrap that would fall away. And what you'd be left with is the reed. Fantastic. The next operation, it would come up, you would push it in again, it would come down again, and it would stamp another reed out. And he managed to do all of this in 1879. He patented the machine, he went on to greatness, he made a lot of money and spent it wisely. He done a lot for the Klingenthal area. If you want to read more about Julius Berthold, you need to go onto my website and download my little book. But that's how he done it. He built a sequential die that basically you feed the brass in, and in 2 operations it would stamp a reed out. This one is 1 operation, and this increased production by the millions. So there you are. That's the history of how they made reeds. Let's get back to making our reed machine. So I hope you enjoyed that little history lesson there on reeds. So I finished now doing all the lapping on the blocks, and I'm ready really to put it together to do a bit of a dry run. Tea break first. But what I wanted to show you was how we're checking the tools themselves. This is one of the blades that I've made that's going to cut the reed out. A little bit like we saw on the little history lesson there. And it's very important, this here, the critical dimensions of this is that these sides here are very parallel, because these are the sides that are going to cut the reed out. So they need to be very, very parallel. It doesn't really matter about the width of them, as long as they're very, very parallel. The way I'm going to check that is that I have here, it's quite an old comparator gauge. It's got a Mitutoyo gauge on the top, digital gauge. And what I have, just to calibrate it, and you can see this, I'll bring it out maybe, very heavy. Oh. You can see here that it's set to 0, 0. I've zeroed it in on this bottom plate, and here is what we call a calibration gauge. This is like a slip gauge, and it's, oh, you can't really see that, but it's dead on. See the shiny, the glass looking, the mirror finish faces? They are exactly 10 mil. This is exactly 10 millimeters, and it comes with a certificate to say it's a grade 1 or a grade A calibration block. And if we put this under here, this is put at 0, this should be read 10mm, exactly 10mm, right across the block. So we can zero it in here, we zero him in and we lift it up, and we can zero him in. You can see this, it's actually gone to 10.1. Oh, 10mm, 10 there. It's probably going to move as I carry it. You can see that it says 10mm. Now, if I move this along here, it should still say 10mm all the way along, because that is 10mm all the way along. Now, what we need is to put our plates under here and see whether these plates are exactly parallel. So we can put these under this little comparator gauge, and it reads currently 4.4. So it's 4.4 at the tip, and we need to push him along here, and we keep pushing him. If we can push him along here, if you hit, if there's anything on this plate, it's 4.04, and it's 4.04 from one side to the other. See that there? Look, 4.4, 4.04 all the way along. And if we go the working phase, which is about 12mm from the tip to the bottom, it's 12.4, 12.4 all the way along, 12.04. So that plate here, which is our blade that's going to cut the reed, which has been lapped, you can see it there, it's sort of a dull finish, is exactly parallel all the way across, which is exactly what we wanted when we stamped these reeds out. So that's how we've checked the blades. We've used our little Mitutoyo gauge here. If you want to buy one of these, you can get these on eBay. They're not too expensive, they're not cheap. There are some Chinese versions of this which are not too good. I've sort of got a, dare I say it, a Chinese version of this thing here, where it clamps up, and this reads all different measurements here. So I sort of, when I use this for sort of making rough parts, especially milling parts. But when we get down to the final finish of the parts, we really need to get onto products like this. So that's it. Keep watching. Hopefully the next video will show this particular tool finished, and we're probably going to make some paper reeds. Here we are. Can't use them, but if we can make them in paper, we can certainly make them in brass. So that's it. Please subscribe to the channel, somewhere along the bottom here, don't know where, but subscribe, and keep following our progress in making a harmonica. Thanks very much.